Ah, 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 ah.
Hi, I'm Dr. Meredith Gray, and today we're going to be talking about the musical brain. Why does a beautiful song send chills down our spine and bring people to tears? How do some songs have the power to make us happy, while others cause us to cry? How can a series of sounds with no apparent function be such a critical aspect of cultures and communities around the world for thousands of years?
Processing music is a multi-step operation starting in the ears and going into the brain. The journey starts when the person listens to music and the sound waves travel into the external middle ear, where they are converted into fluid waves in the inner ear. When these vibrations meet the basilar membrane and the cochlea, the inner hair cells, which serve as sensory receptors, generate electrical signals sent into the auditory nerve, where they are passed along to the brain. The individual hair cells are turned into different frequencies of vibration. Neighboring cells have similar frequency ranges to create a frequency map covering a broad spectrum of noise with no gaps.
It was found that in rats' brains, when exposed to a series of noises, rewired cells to recognize important sounds better by dedicating a larger area of the cortex to that noise. So in theory, our brains do this too. Music is processed in our brains the same way as important noises in rats. I wanna testify, scream in the holy light. You bring me back to life, and it's all in the name of love.
That sounded like an important sound. Like language, music is a form of communication. Both language and music have set conventions and orders that they are governed by to set a right order of combinations and elements. This means that our brains can process music in a similar way as language.
Because music encompasses a variety of complicated elements, among which are frequency, tone, pitch, harmony, melody, etc., it has been processed in different ways in different parts of the brain. An important aspect of music is contour, the way pitches rises and falls in patterns. Neurons in the auditory cortexes of cats have varying amounts of discharges accompanying varying with the contour. Brain responses vary based on factors such as where a specific tone is placed within a specific melody.
Research is lacking in melody, rhythm, harmony, and timbre, but the areas that respond to each have generally been found. Rhythm activates one hemisphere of the brain, but the specifics are still up to debate. This is because of the fact that different rhythms demand different measures for processing. However, harmony seems to find its home in the right temporal lobe of the auditory regions, and timbre takes hold there too.
Different hemispheres in our brain perceive different elements of music. For example, our left hemisphere focuses on the element of pitch. The focus of the listener and their experience with music has an effect on what parts of the brain are activated. So, when the brain of an amateur musician processes rhythmic relations, that person utilizes the premotor regions as well as sections of the parietal lobe in the left hemisphere. When the temporal relations are more complex, the premotor and frontal lobe regions of the right hemisphere become active, which focuses on pitch and melody. The right posterior frontal lobe and right upper temporal lobe convolution are active when a musical person compares different pitches. These tones are stored for use in the future and to compare the auditory working memory that is in the brain's temporal region. Listen to this. I don't wanna live forever, 'cause I know I'll be living in pain.
Oof, try it like this. I don't wanna live forever, 'cause I know I'll be living in pain.
I get it.
The brain processes music through the primary auditory cortex, which can help with music perception in pitch and contour, which is the basis for melody. Over time, the primary auditory cortex becomes more and more responsive to sounds and musical tones.
Listening to music sets a chain reaction of responses in the brain in order to process it. Perhaps the complicity of music is why it resonates with so many varying human emotions, and why music is a staple for so many cultures around the world.
That demanding hand gesture. Hold on. Okay. Process. No. Wait. Hold on. Okay. I can do it. Ooh, this is so weird. Okay. No. Wait, just stop it for a second.
Research is lacking in melody, rhythm, harmony, and timbre, but the areas that respond to each have generally been found. Rhythm activates one hemisphere of the brain, but the specifics are still up to debate. This is due to the fact that different rhythms demand...
Julia!
Like language, music is a form of communication. Both language and music have set conventions and orders that they are governed by to set a right... Oh, that sounds so weird. Did you hear how I said language, music... thousands of years.